Hello everybody, I'm Federico Santinon of Euclid Labs company, and today I will present you Obelisk. Obelisk is our main bending software, and it is a software particularly useful to design and to implement a new work cell. And so in phase of drawing and of definition and functionality of your real application, in our 3D environment it is possible to define all position of the components of the work cell and to design the gripper and to define which robot and which components it's better to use than other ones to your real application. In particular, in this tutorial, I will perform a new product, and in particular, I will use the SCPX format file. This is a particularly useful file in which are contained inside more information about the bending step, the bend sequence, the angle, the direction of the bend you want to perform with your product. Let's perform a brief preview of the work cell in our 3D environment. As you can see, in the middle we can find our robot. In this kind of application we have a KUKA robot. Then we have here the stack in which you can pick the sheets. For example, a lot of mixed part all together. Then we have the aligner in which you can deposit the metal sheet after having it picked from the stack. Then we have the grip stand in which you can change the position of the gripper of the robot or change the face of the product so the robot can change the way you take it. Then obviously we have the press brake, which we will perform all the bends regarding to that product. And then we have the unloading system, for example the aero pallet, or in alternative the belt. Okay, now we can start. We can select a new product. Here we can, on the filter, select the SCP files, and we select it. Now in the list we can see the software, give an information about us that we contain. In the software already contain the information about the punches and ask us if we want to replace them or not. I said yes. Same thing about the eyes again, and same thing about the holder. It means that in our folders already contain the XF about the tooling set providing the press brake. Okay, now we have the DXF of the part. Like we can see, let's check before the layers. The white one is the contour. The red one are the bending layer, and the last one are the holes colored by green. Then we have to select the properties related to this product. The gripper, I select this kind of gripper that have this kind of angle of 45 degrees between the flange of the robot. Then we have to select the stack, the aligner, and the pallet provided to bend it. Okay, now we have it on our list and I can select it. Like I said before, with this kind of format, the SCPX file, all the information about the bend sequence, the order of the sequence, or the angle and direction of the angles are already all contained inside this kind of file, such as all the information regarding to the tooling set provided on the press brake. So like we see before, the punches and the dies that we must use to bend this kind of product. If this kind of DXF are not provided inside your press brake folders, these are auto-generated and you can find them directly inside the press brake folder. Now this kind of product have 8 bends, and we will perform all the process from the beginning, from the stack, the bending steps, and then at last the palletization. At the end, we will generate the global trajectories, and if everything is okay and no errors occurs, we can generate the final robot program that we can run directly in our machine. Okay, now we can start picking the metal sheet from the stack and then to align them on the aligner. I usually prefer to start from the first bend, so I can set from here the position of the gripper on the part and then go back to the loader step and select the position of the product on the component. Okay, by now we can select from here the position of the gripper. on the part. We can perform a rotation like this, maybe a little backward. Okay, good. And now we can select and set the position on the loader system. This is the first one, this is the stack. We can move it as we wish. You can see in all direction and rotation. Okay, good. We can test the bottom and the top position to see the reachability and if any collision can occur. Then we can test the repick and the release position. Maybe from this kind of product, better to rotate it. In this way, it will be also more simple for the robot to reach it and to reach that position without changing any kind of configuration. You see, also from here, it is possible to move them, okay, according to the position of the component we choose. Repick position and release, it's wrong because we are still in custom. So we want the position of the gripper from next. We still have any collision. We auto position it. Good, let's test again. Also the stack, good. Loader step is complete. Now we can start with the 8 bend steps. This is the first one. We already choose the gripper position, and for the following option we choose follow. We can test the bend now. Press brake comes down, pinch point, then bend. Robot follows, and everything is okay. So good, we can go on to the second one. Also from here the position seems good, the bend position seems perfect. Also for this kind of bend we have follow. We can test it again if everything is okay. Okay, perfect. Now we can go to the third one. Follow. This 135 degrees from previous bend the position of the gripper. We can test it again. Okay. We can go to the fourth bend. Okay, we reached the fourth bend from the top of the metal sheet. So now I suggest to use a kind of regrip on pinch to perform a bend like this. Okay, so the deposit from the previous one is this, and then we can change it. Let's select the second gripper position, that in this case it is custom. Let's turn it to 0 and test if the repeat position is good. Okay, sorry. We have to change phase, go to the other side, and maybe change the angle. It seems quite good. So at the end of the bend number 3, robot reach this position in this way, and then the press brake will come down. Robot change the position of the gripper on the product and follow it. Let's test the bend if everything is good and it's okay. Perfect. Now we can go on. Now we have this position of the gripper on the part. And from the beginning of the bend number 5, it seems not quite correct. So I think it's better to use the overturner for the regrip stand to change the face and the position of the gripper. First, let's select the position we want to use to regrip the product on the regrip stand. Let's try to use everything to 0, and we can try to change the face to repick the sheet on this face. While I change the face, you can see the ghost gripper that changes according to the position we want to reach. Now we can go to the advanced option. We select the usage of the grip stand, and we can edit the position of the product on the grip stand. We first adjust the angle, and then we can adjust the position. Okay, we can test the position of deposit given by the previous bend. Okay, and this is the repick from the actual one. Perfect. Now we can test. By now we have collision. Maybe the face is not good. Let's try with this one. Again, not. What about if we reverse or we invert? You see, it is not the error, but we have collision because of the position of the gauges. If you want to recompute them or to position in a different position, you can set the gauges section or to manual if you want to globally manage the position of each single axis of the gauges. Otherwise, you can recalculate and recompute the position of them. Okay, so this is the starting position of the robot to begin this kind of bend. And we can select here save position and edit so the regrip position on the bend. Like we did before, we can change the face. It seems better than before. We can move it just a little bit down. And we can set the save position. I usually go to the repick position at the end of the bend, and I move in Tool, Z, and I set the save position as close as I can to this one. In this way, robot performs something like this. After using the grip stand, we have the deposit, then the press brake will come down, go to the pinch, so now robot will go to the save position and go to repick it. If everything is okay, we can check it with a test bend. Perfect, everything is green. We can go on. This positioning, good. We have the following option with always 135 degrees. We can test it. Also, this step is successful. Now we can start bend number 7. Before I'll start, pay attention to one detail. I mean, you see the position of the gauges for bend number 7 and bend number 6. Before we reach the position of the deposit of the gripper on the part on the dice of the press brake, we have to wait to position the gauges, otherwise we crash inside it. So for this bend number 7, it is better to use delay. In this way the robot will come here, will deposit the product over the die, and then the gauges can position them. Okay. To perform this kind of bend, I suggest to use regrip on pinch. So this is the deposit. The press brake will come down, and then we can set it as we wish. Okay, it seems good in this way, like before. Let's test step number 7 with the regrip on pinch option. Okay, that's really good. Let's go to the last bend. The start positioning seems very good. We can test it again. Perfect. So the product is finished and we finished the bending step. Last but not least, it's the last one regarding to the palletization. To begin the palletization, I want to make you see some advanced feature, such as the usage of two styles with the usage of the grip stand and the alternate palletization. So let's begin from the first style. First, for the first style, I want to use the overturner. So let's set before the position of the first product you want to bend and you want to palletize, sorry. And then with the offset, we can progressively manage and finish all the products. Let's set the custom position of the first one over the pallet. I want to change it from the other side. And then the base position, that is the first position of the first product. We can move it. Of course, we can move up, turn it on from the other side. It seems very good. I want in this position. Then I want 2 rows, and so I have to set the offset of rows. If I want to see the products growing, I have to increase this scroll bar. Okay. And then we have to set the fixed position in which 2 pallet trajectory will finish. Remember that the robot configuration of the fixed position and the deposit position must be the same. So I suggest you to go to the deposit position and then move it by manual to keep the same robot configuration. For this kind of product, I prefer to use a local part fixed position, and I can set it. Now we can see all position, if all positions are right or they are wrong. All the deposit position, we can see a mistake. I mean that the robot configuration between the first one and the second one changes. So it can cause many mistakes on your real application. So let's correct this one. In this way, the first position and the second position, when robots go to deposit them, will have the same configuration. So if everything is correct, we can now test all position and check if the deposit position and the part fixed position we choose are correct. Okay, we have an error like this because we move the base position. So in this way, the base position should have a different robot configuration about the part fixed position. So we can set it again. We can close the each pendant. We can go to the first deposit and test it again. Perfect. Now all the 3 positions, the part fixed position and that position, have the same robot configuration, and so it's pretty good. Now we can choose to use the regrip stand, and we have to set the regrip position of the part on the regrip. We can set first the angle, then we can move it like before. Okay, you can adjust the deposit. It is the end of the last bend in the regrip, and this is the peak position we choose for the first style. Sorry, I do not test. Okay, that's everything green. Perfect. To palletize this product, we choose 2 positions. The second gripper position is okay, and it's given by the last bend. We have just to set the base position of the first one. Something like this. This is the first position. Let's move it again. I want to move a little bit up. And maybe rotate it. Perfect. Also, for the second style, we want to use 2 rows, and we have to set also the offset, and we use it the same value we used for the first style. Okay. Last, the fixed position. That is the last position reached by the robot on the trajectories to pallet alternate. We start always from the deposit position and we move it like in this way, but you can choose whatever you want. Use the local one and set it. And like we did before, we can test all position on the pallet. Really good. In alternative, we can use the alternate palletization, and the result will be like this. Perfect. So by now all the steps has been completed. We can save it. Okay, that's been saved successfully. And now we can generate the trajectories. Of course, we can also perform the preliminary checks. There are some important checks that help the user to understand if any mistakes has been made, like in this one, or other collision or errors, any kind of errors. I do not want to continue. Let me read the preliminary. I have the collision with the alternate palletization between the belt and the robot. Okay. Sorry, I wrong button. Let's check it again, like this one. Of course, because I change it. This is the first one. Okay, let's test again. It seems good. Now we can do it again with preliminary checks. Okay, that's perfect. All the steps are completed successfully. Now we have to wait that the robot perform all the trajectories, and then we can analyze the results. Okay, perfect. As you can see, trajectories computation is finished, and Obelisk, after preliminary checks, successfully calculated all the trajectories. It takes around 11 minutes, and the process is in this way finished. So we can close this window. First we can save it. Sorry, we can save it. Okay, it can take just a quite a bit time because all the trajectories are quite heavy, and we have 8 bands, so we have a lot of material to save. Okay, good. Then we can see all the simulation of the final process from the beginning to the end, and the pick from the stack. And then we have the usage of the aligner, and then we can go to bend it. Okay, and now we have the last trajectories are related to the palletization from the last band to the pallet, and then we have from the pallet to the next, and from the pallet to home from both the styles. Okay, so as we can see before, remember you that the final result is a pallet scheme like this. Okay, perfect. So the process is complete. Last, we can generate the robot program and send it directly to your real application. Now we can generate it. Press brake program has been generated successfully, and the same thing for the robot program. Perfect. Your job by now is complete. Thanks for your attention and have a good job.